Hi, 7th graders. We're on lesson 12:12, probability of compound events. Starts on page 637 in your textbook. Our learning target is I can find the probability of independent and dependent events. So if we have a sale that is advertising that if you buy an item from the column on the left, you get a tote bag free. Suppose you choose items at random. So we can look and we can see what is the probability of buying a beach towel. Well, we know now that to find the probability of an event, we would add up all of our possible items or outcomes that could occur, right? So there's 6, and the probability of buying a beach towel then would be 1/6. Probability of receiving a red tote bag would be 1/3 because 1 is red and there's 3 total. The product of the probabilities, so if we multiplied 1/6 times 1/3, we would get 1/18. And then we can draw a tree diagram to determine the probability that someone buys a beach towel and receives a red tote bag. And we know that from the fundamental counting principle, we would get the same answer. So we would get that there's 18 possible outcomes. And so our probability would be 1 out of 18 to get a beach towel and a red tote bag. So our vocabulary compound event consists of 2 or more simple events. And we'll talk about this more as the video goes on. An independent event is the outcome of one event that does not affect the other event. So for example, to find the probability of independent events, we would write it as P, comma, A and B. So basically that means the probability of event A and event B equals probability of event A times probability of event B. So an example of an independent event is if one letter tile is selected and then the spinner is spun, what is the probability that both will be a vowel? They are independent because if you pick a letter tile out of this group of letter tiles here, and then you spin the spinner, the probability on the spinner of getting any letter does not change no matter which letter you choose out of the letter tiles, and vice versa. So they are independent because they are totally separate. Picking a tile does not affect what goes on with the spinner. So the probability that both will be a vowel. So we would write it as, well, the probability of selecting a vowel of our letter tiles is 2/7 because there's 7 letter tiles and there's 2 vowels. So 2/7. The probability of spinning a vowel is, there's 6 different spaces on our spinner and they're all equal. So actually the probability of spinning a vowel would be 2/6 because there's 6 spots and there's 2 vowels, but 2/6 simplified would be 1/3. Probability of both letters are vowels, we would take 2/7 times 1/3 and we get 2/21. Okay, so the probability that both letters are A's. Well, the probability of selecting an A would be 1, there's only one A, so it'd be 1 out of the total number of tiles, so 1/7. And then the probability of spinning an A would be, there's only one A, and there's 6 spaces, so that would be 1/6. So if we write this, then we would have 1/7 times 1/6. 1/7 is the probability of selecting an A from the letter tiles. 1/6 is the probability of spinning an A. Multiply them together, we get 1 out of 42. Okay, probability that both are consonants. So I want you to pause me and figure out the probability that both are consonants. And I'm going to scroll up so you can see here. Okay, so we know that there is 1, 2, 3, 4, 5 consonants. So I'm actually just going to write this up here. 5/7 is our probability of getting a consonant from our letter tiles. And then there's 1, 2, 3, 4. So we have 4, 6, because there's 6 spots. So then our answer would be 20 over 42. And we can simplify that down to 10 over 21. So the probability of getting both consonants is 10/21, or 10 over 21. And 10 is really close to half of 21. So we know that our probability is about 50% to get both consonants, which makes sense because there's a lot more consonants than vowels. A spinner and a number cube are used in a game. The spinner has an equal chance of landing on one of 5 colors: red, yellow, blue, green, and purple. The faces of the cube are labeled 1 through 6. What is the probability of a player spinning blue and then rolling a 3 or 4? So this is an example of independent events again. Okay, so we are asked to find the probability of the spinner landing on blue and rolling a 3 or 4. The events are independent because spinning the spinner does not affect the outcome of rolling a number cube. So first we need to find the probability of each event. So the probability of blue is, because there's 5 colors, so we have, because we have 5 colors, 5 is going to be on the bottom. And then the number of ways for us to spin blue is 1, because there's only 1 spot with blue. So the probability of getting blue is 1 out of 5. The probability of getting 3 or 4, there's 6 faces on the cube, so that's why 6 is on the bottom. 3 or 4, so there's 2 options. 3 is 1 and 4 is 1. So that's 2/6 simplified down to 1/3. Then we have to find the probability of both events. So we would write probability of blue and 3 or 4. So we would take 1/5 times 1/3, and we would get 1/15. And that would be our probability of getting a blue and then 3 or 4. And that was answer C if we go way back up, 1/15. Okay, so now if we have dependent events, that's the outcome of one event affects the outcome of another event. So the way that we solve this, the probability of A and B, we would take the probability of A times the probability of B following A. So what does that mean? Here's an example. There are 4 oranges, 7 bananas, and 5 apples in a fruit basket. Megan selects a piece of fruit at random, and then Terrence selects a piece of fruit at random. Find the probability that 2 apples are chosen. Okay, so we're talking about someone taking a piece of fruit out. So Megan is taking a piece of fruit out and she's not replacing it. So the first event affects the second event, because not only will there be less fruit, but there will be less amount of the fruit that Megan picks. So that's why they are dependent. So the probability that the first piece is an apple, we know, would be 5/16, because there's 5 apples, and then we get 16 by adding everything together. 5 plus 4 is 9, plus 7 is 16. So the probability of Megan getting an apple is 5/16. The probability that the second piece is an apple is that, so because she took one apple out, there's only 4 apples left in the fruit basket. So now we need to change Terrence's probability to 4, because there's only 4 apples for him to choose from in the basket. But there's also, that apple is gone, so there's only 15 pieces of fruit left. So see how the probability changes for Terrence after Megan selects her fruit. This is why these are dependent events. So then to find the probability that they both get the apples, we would take 5/16 times 4/15, and we would multiply them together. They did cross products and canceled out here, but you could multiply them together and you would simplify it to get 1/12. So the probability of 2 apples then is 1/12. Okay, we're going to do a couple of these together and then you're going to do a couple on your own. So the probability of 2 bananas. I'm going to go back up here and we're going to reread this. So there's 7 bananas. Okay, we want the probability of 2 bananas. So the probability that our first piece chosen will be a banana is 7/15. Okay, now if we go in and take another piece of fruit and try to get a banana, we only have 14 left. Oops, I'm sorry. We started with 16 pieces of fruit. This should be 16. 7/16, and then this should be 15. I was a little ahead of myself, but I'm glad that I caught that. And then our top would be 6 because there's only 6 bananas left. So we have 7/16 times 6/15. And we would multiply those together and get, I have my simplified answer, but, so we have 16 times 15 is, so we have 7 times 6 is 42 over 240, which simplifies down to 7/40. Okay, and then if we check, we have 7/40. The probability of an orange and then an apple. So there's 4 oranges and 5 apples. So I'm going to rewrite this right here. 4 oranges, 7 bananas, 5 apples, 16 total pieces. There we go. My computer's freezing up. Okay, so the probability of an orange and then an apple. Okay, so we have probability of an orange. I should have wrote the other ones like this too. So probability of an orange then would be, there's 4 oranges to choose from, so 4/16. Then probability of an apple would be 4/15. Okay, then we would take 4/16 and multiply it by 4/15. Oh my goodness, there's 5 apples. Seriously, you guys, where's my mind tonight? So probability of an apple would be 5 because there's 5 apples. I was thinking of bananas. I better just stop and have you guys do the rest of the problems on your own. So we would have 5/15. Okay, we multiply together and we get 20 over 240. And then our simplified, we can simplify that down to, we can divide 240 by 20, and we get 12. 20 divided by 20 is 1. So our probability of getting an orange and then an apple is 1/12. And we can check to make sure, 1/12. I would like you to pause me and do F and G. Probability of apple and then banana, and then probability of 2 oranges. So if we have F, probability of apple and then banana. So we would have 5/16 times 7/15. So you should have 35 over 240. And then that simplifies down. You should always get it into simplest form to 7/48. And then G, probability of 2 oranges. So again, how many oranges are there? 4. So we have 4/16 times 3/15 because we're picking for the same fruit. We already removed one of the oranges. So we have 12 over 240, which equals 1/20. All right, so you need to, let's check to make sure that we have the correct answers. If you need to go back in your textbook and relook at some of the problems, otherwise make sure you log into NICU and take the 12-2 NICU quiz. Have a super evening.